This is one of those details that looks simple, until you try to understand how the airtightness layer, the insulation, and all the fixings go together. Most problems at windowsills come from not knowing which layer takes priority, or where one starts and another one stops. In this episode, we'll look at everything step by step and see how all the different layers connect. This is a windowsill detail for a masonry cavity wall with a solid timber window. By the end of this session, you'll understand how the DPC and sill protects from moisture, where the sealant should be positioned, what the insulated cavity closer does, how the airtightness layer connects to the base of the window, and how everything combines for a good solid junction. Okay, let's jump in. Welcome back to the Detail Clinic, brought to you by First in Architecture. This series uses a real student markup to explore different detail junctions and answer common questions and explain how to critically think about construction details. Let's start off by introducing you to some of the common elements we'll come across when looking at a windowsill detail. The damp-proof course is a waterproof barrier laid beneath the windowsill and lapped up the sides to stop moisture tracking into the wall or frame. The flashing is a weatherproof covering, often metal, that directs water away from the window junction. The sealant is a flexible silicone or polymer mastic used to seal small movement joints between the frame and surrounding materials, preventing water and air leakage. The airtightness tape is used to create a continuous airtight connection between the window frame and the wall structure. A cavity closer is a rigid or semi-rigid insulated component that closes the opened end of a cavity around the windows and doors. It reduces heat loss and provides fire resistance, 30 minutes in this example. Galvanized window straps are metal strap fixings that fix the window securely to the surrounding structure, often with expanding foam or mineral wool to fill the gaps. Let's take a walk through this detail. This is a busy part of the wall where the window, structure, waterproofing, and airtightness all meet. Getting this junction right is essential to prevent water ingress, reduce thermal bridging, and maintain airtightness. Let's go through the components and clear up how all of this works. So starting from the outside, the windowsill sits proud of the brickwork below with a drip groove on its underside to throw rainwater clear of the wall face. Directly beneath, the DPC runs under the sill and laps up the sides of the window frame. This is critical. It stops any water that makes its way through the sill from entering the wall. At the junction between the frame and the wall, where the packers are, a flexible sealant is applied externally. It seals the packing and visible gap between the sill and the frame. The DPC and sealant perform complementary roles, so one is the hidden sort of waterproof layer and the other is the external weather seal. The window is positioned central to the cavity to maintain the thermal line. We chatted a lot more about that in episode 4, so be sure to check that out. Inside the cavity, the insulated cavity closer runs along the jamb and around the window. In other words, it sits both horizontally below the window and also vertically on either side of the window. It closes the cavity edge, providing thermal continuity, and as I said in this example, it's a 30-minute fire resistance. The cavity closer isn't exactly the same as a cavity barrier, though both contribute to fire safety. The closer is kind of more like a finished edge component, while the cavity barrier is purely for fire separation. On the inside face, the air tightness tape seals between the window frame and the internal reveal. The blockwork leaf has a parge coat for air tightness, and the wall is finished with insulated plasterboard for thermal performance. The galvanized window straps secure the frame to the structural blockwork, while expanding foam or mineral wool ensures that the gap around the frame is fully filled without creating any air paths and reducing thermal bridging. So let's jump into the student questions. The first question explains that the student is having a hard time picturing how all of this comes together. So you want to think of the sill detail as a system with layers that each have a job. So the flashing is for surface water runoff and shedding the rain, and the sealant is for wind tightness and to ensure a clean junction between the window frame and the DPC. Next question, what is this? So we're looking here at the galvanized strap and the foam. So the galvanized strap fixes the window securely to the structure, and it does this, it allows the kind of offset of the window, so it's not sitting on the blockwork, it allows us to offset it into the cavity, and therefore the thermal line. And the expanding foam or the mineral wool around it kind of fills those gaps to improve the thermal and acoustic performance as well. The next question looks at, does the sealant go over the DPC or does it sit next to it? And I can see why that can look a little bit tricky. So the DPC runs below and behind the visible joint, while the sealant finishes the external face, sort of bridging the small gap between the frame and the sill for weather protection. The final question we're looking at from the student today is the insulated cavity closer similar to the cavity barrier from earlier? So that's from a previous video. So they are related, but they're not the same. The cavity closer seals the end of the cavity at an opening and provides thermal and fire resistance, whereas the cavity barrier stops fire and smoke spreading through longer cavity runs. It doesn't form like a finished edge. So some of the key points of this detail: the DPC must be continuous below the sill and lapped up the sides to prevent moisture ingress. The sealant goes over the DPC, sealing it in place and providing a flexible surface joint. The flashing or sill drips direct water away from the wall face. The airtightness tape connects the internal airtight layer to the window frame. The insulated cavity closer provides that thermal and fire performance at the reveal. All the fixings should be stainless or galvanized to resist any corrosion issues. And you always need to check compatibility between the sealant, the frame material, and the DPC type. Make sure everything goes together well. As always, the specifics of a project really do matter. So things like the substrate, moisture, exposure, different finishes, acoustic and fire requirements, the warranties or insurance requirements from manufacturers, manufacturer guidance, all of these can shift the final arrangement. So as we keep on saying, there is always more than one way to design a detail. You can download the free student pack for this episode, which includes the fully annotated sill detail, a glossary of all the terms that we've mentioned during the video, the wash checklist for this junction to guide you in the general principles of this kind of detail, and the key points and design considerations. Find the download link in the video description or just visit First in Architecture. Thank you so much for watching. Please share this video with anyone else learning about construction detailing. And as always, happy detailing.